So pairwise sequence alignment, what is it? Well, this is comparison made between two sequences. There are many distinct alignment options that are possible, or outputs that can be generated. The goal here is to find the one that has the highest matches or the best scoring one of them. Obviously, some sort of scoring is necessary for one to be able to do that. And there are various scoring methods that are out there and schemes, and we shall talk more about those. And also remember that sometimes there's more than one solution with the same best score. Gaps are needed in a global alignment, but they come at a cost, and this is handled variably. One way is to introduce a constant gap penalty. This is a fixed negative score that's given at every gap, irrespective of the length. So, as an example, if you're aligning these two sequences, this alignment will score as follows. You'll score the positive one for the matches, and then you'll have this region of a gap, even though there are really three of them, but because we are scoring just a region, the negative will be just 1. So the score will be 7 minus 1, which gives you 6. So to enhance or to optimize the score here, just be careful or worry about the number of gap regions that you introduce, and this one should be as few as possible. A second way is to introduce a linear gap penalty. This one is a per unit length of gap, so it takes into account the length of the gap. The previous one did not take into account the length of the gap, it was just the region. So scoring this same sequence using this criteria, again, you'll score the positive alignments, which is 7, and then you have to subtract the individual gaps, which makes it 3. So 7 minus 3, the score here is 4. So the previous gap penalty options, the constant and the linear, do not consider whether gap is opening or extending. Also, gaps at terminal regions are treated with no penalty because many true homologous sequences can be of different lengths. A third gap penalty, called the affine gap penalty, factors the opening and the extension of the gap separately into the total gap cost. So the total gap cost includes the opening and the extension, and they're all factored into this. So this has advantages and disadvantages. It's good because opening of a gap is costed more than extending it. So you get that flexibility because that's more evolutionarily sound. The drawback is penalty points are arbitrarily chosen. This is an illustration of possible solutions to alignment between this sequence and this sequence. Just note that various alignments are possible, obviously, and more than one can have the same best score as shown in these 3 examples. And also note that the supposed gaps or overhangs at the end are really not considered as true gaps in this case, so they are really not penalized. So we've learned how to score an alignment, but how do we really make one, and using which methods and for what situation? When you have short and very related sequences, by hand can work. Just slide the sequences on 2 lines of a word processor and you'll be able to compare them and align them. That's easy. However, when that's not the situation, you can be more advanced a little bit, and you could do using a dot plot matrix. So these methods allow you initial exploration of your sequences to discover small patterns, for example, repeats, insertions, or deletions. This is one of the simplest comparison methods that is in existence. If you want to do more intensive comparisons to arrive at the best alignment that can be attained, you have to consider a rigorous mathematical approach, and there are dynamic programming methods for this. Of course, they're slow, but they guarantee to give you an optimal alignment. If you're doing extensive comparisons involving long sequences and you want to look at entire genomes, for example, or a large set of sequences, for example, such as found in database entries, then you need heuristic methods. They're fast and approximate, but they're not very accurate. So for more on this will be continued in session 2 and session 3.